Hey everybody, a little while ago here on the channel I made some crucibles out of backyard clay, and today I'm going to show you how I fired them and what the result was. So before pottery is fired, it's called greenware, and at this stage, even after it is totally 100% bone dry, it is not actually very useful, and the reason for that is that if you get it wet, it basically just reverts back into moldable plastic clay again. But if you fire the pottery, you actually chemically change it in a few different ways, and then it becomes real pottery and not just a pot-shaped piece of clay. Now, firing pottery is actually a really tricky and delicate process, and that's why usually you would want to use a kiln. It's just way easier to regulate the temperature in an oven that has been built specifically for firing pottery. But I do not have a kiln, so I'm going to go ahead and push the limits of the technology just a bit and use our old smelting furnace. Like I said, firing is a tricky process. One of the most important chemical changes is that you're actually driving chemical water off of the greenware. Even after the greenware totally dries, it actually has water that is chemically bonded to the clay particles. And that water gets driven off of the greenware between 200 and 1000 degrees Fahrenheit. But if you drive it off too quickly, then it actually escapes as steam and the pottery explodes, and that's obviously not so good. So you need to raise the temperature, but you need to raise it pretty slowly. And in a controllable kiln, this would be easy, but in my case, I need to take some extra measures. So this is my strategy. I'm going to put the pieces close to the fire, and I'm going to rotate them frequently, and I'm going to gradually move them closer until I can finally cover them with the fire. I also have an infrared thermometer that I'm going to use to monitor the temperature of the pieces. When they get 50 to 100 degrees hotter, I'll move them a bit closer to the fire and keep rotating them. Now, my infrared thermometer only goes to about 600 degrees Fahrenheit, which means that the last temperature range between 600 and 1000 degrees I'm just going to have to estimate. But I figured it was still better than nothing. If you want to buy one of these, I'm adding an affiliate link in the video description. For me, it made the process way less stressful. It actually took me about an hour to get the pieces to 300 degrees Fahrenheit. I think that might be a little on the careful side, but I figured better safe than sorry. Oh, and by the way, seriously, don't put your unfired pottery straight on the coals. It will explode. It has to happen slowly. I sped up the next section and got all the pieces from 300 to 600 degrees Fahrenheit in only about 30 minutes, or about 10 minutes for every 100 degree increment. And this was partially because I was getting impatient, but also partially because the physical space was getting a little difficult to work with. Anyway, I think that must have been a little too fast because one piece exploded. Rip my crucible. The other two seem to survive okay up well past the range of my thermometer, though. Once you've gotten it to 1000 degrees, you can pretty much just crank up the heat as fast and as far as you want. More chemical changes happen the higher the temperature gets, and in general, a hotter temperature is better. The next big chemical change happens from around 1300 degrees to 1600 degrees Fahrenheit, and at this stage, the clay particles actually sinter together. You're pretty much welding dirt, which is actually really awesome. To measure the temperature at this range, I used an iron bar. Iron changes color quite a bit in this temperature range, so this piece of rebar is basically a color-coded thermometer. It's hard to tell the color in the sunlight, so I also bent it to see how easy it was to work. My best estimate is that the fire got up to between 1600 and 1800 degrees Fahrenheit, so not too bad. It's best to let the pottery cool somewhat slowly as well so it doesn't get temperature shock, so I just let the fire burn and slowly die out. The next day, I took out my pieces to see how the firing went. One piece really shattered. I was pleased to see that at least the pieces seem to have fired well. They clink like glass now, which is what you want. My other two pieces are showing some cracks, which really worried me at first, but they actually do seem to be pretty structurally sound. So I am definitely going to glaze them and at least try melting metal in them. I'm just going to hold them far away from my body so that I don't pour molten metal on myself accidentally when the crucible breaks. I think the 300 to 600 degree range was where I moved them too fast, most likely. I would estimate that you need maybe 15 minutes for each 100 degree rise in temperature, but as always, slower is safer. So there's my homemade crucibles. Whether they're going to glaze well and hold molten metal remains to be seen. I'm really excited. If this works, it's just one more piece of an industrial process that you can do by yourself in your backyard. Thanks as always for watching. We'll see you next time.